Right, a very good afternoon, ladies and gentlemen. This is your host, Dipanshi, and I extend a very warm and hearty welcome to each and everyone present here. Thank you so much for taking out time from your hectic schedule and beautifully marking this spectacular day with your glorious presence. Thank you so much, everyone. So can we fill this room with a bit of energy? Can we give it a huge round of applause, everyone? Thank you so much. So welcome to Renewable Energy India, REI. I guess this is the most important thing we need. This is the need of the hour. Can we say that? Is renewable energy the need of the hour? Am I right? Can I get a yes on that? Definitely. So taking no more time, let's carry forward. So this session is powered by Council on Energy, Environment and Water. The topic will be pathways to build a resilient and secure supply chain for renewable energy technologies in India. This session will bring together experts to discuss the opportunities and challenges for India as it aims to secure the supply chain for renewable energy technologies and leverages the opportunity of global diversification. So, moderator for this session will be Mr. Rishabh Jain, Senior Program Lead, Council on Energy, Environment and Water. Sir, can we have you on stage? With a little round of applause, everyone. All right, so let's invite the panelists for this session. I would like to invite Ms. Priyanka Mishra, Director and Country General Manager, Umicore India Private Limited. Again, with a huge round of applause, everyone. Have a seat, ma'am. Thank you for joining. So next, I would like to invite Dr. Balachander Krishnan, Chief Operating Officer, COO, INDOSOL Solar Private Limited, SPV of Shirdi Sai Electricals Limited. Sir, please have a seat. Next, I would like to invite Mr. Rajender Kasadi, International Solution Manager, BESS, Envision Energy. Again, with a huge round of applause, everyone. Thank you for being an amazing audience. Last but not least, I would like to invite Mr. Vijayanand Samudrala, CEO and President, Amara Raja Advanced Cell Technologies. Then I would like to invite Mr. Bhaktha Keshavachar, CEO and Founder, Chara Technologies. All right, everyone, thank you for joining. So, sir, the session is all yours. Thank you.
Thank you. Hi, everyone. Good morning. I'm Rishabh Jain from the Council on Energy, Environment and Water. I welcome you as you join this session on renewable energy supply chains for India. Before we begin the panel discussion, and I'm grateful that we have a stellar set of panelists to discuss a very important topic, I just want to highlight a few important points before we go into the discussions. So until a couple of years ago, supply chain or manufacturing was not the most important or interesting topic, at least for the sector. And the focus has always been on the deployment of renewable energy, solar, wind, even batteries, electric vehicles, and so on. But specifically the COVID-19 crisis and the Russia-Ukraine war has reiterated the importance of securing the supply chain, maybe increasing the indigenization of some of these steps, which can lead to economic growth and maybe add to the local jobs for the country itself. At CEEW, we were fortunate enough to work with the government on some of the G20 reports, focusing on supply chains and critical minerals. And what we realized that the countries that are on low-income countries, low-middle-income countries, and high-middle-income countries are more and more vulnerable to supply chain disruptions compared to the high-income countries. This even then calls for more importance for countries around the world, different important stakeholders, that if we have to truly have a global energy transition, we need to bring in partners from across the world and then try to understand that what are the potential reasons that can derail an energy transition and what can countries do today, because there can be significant lag in setting up some of these. With this context, I again thank all the panelists who are joining us today. Some of the sectors that we'll be discussing will be in way advanced stages of manufacturing, both in India and globally, and some of the sectors will be at a very nascent stage. But I'm sure there are learnings from one sector to another. And maybe I'll start with Bala, with you. Solar, uh, there has been a constant push for solar deployment in the country, right? Of course, wind has been there, but in the last couple of years, there has been a dedicated push for solar manufacturing. Despite having the National Solar Mission since 2010, I would say the country only got serious in 2020 after COVID, where we realized that how vulnerable we were and how much import dependent we were. I mean, the numbers were always there, just that we didn't feel that vulnerability. Given that the government has taken multiple initiatives like PLI, ALMM, BCD, there is expected to have significant manufacturing capacities by 2030. Some estimates suggest that we may be touching 100 gigawatts. It's also possible that we may even cross based on some of the numbers that I just heard in the REI Expo. But at the current pace of deployment, we may still be at 25 to 30 gigawatts in 2030. Now the question is that what do we do with some of these excess or extra capacity that may exist in the country? Also, this phenomena is not just in India. There's so much capacity that is coming up in America. Europe is also thinking, and of course, China already has overcapacity. Given all of this, what do you think will be the comparative advantage of India's solar module manufacturers, or what can be their USP as they try to sell modules not just in India, but outside, with or without government support?
Yes, Rishabh. So we were actually one of the few PLI qualifiers for polysilicon to module. So this should be the way to go forward, in the sense that we have to start focusing mainly on integrated PV manufacturing and not just module manufacturing. Traditionally, India has been focusing for the last, I would say, 10 years, we were mainly focusing on module manufacturing and to an extent cell manufacturing. There is absolutely nothing related to polysilicon or ingot or wafer manufacturing happening. So if you start doing from polysilicon to module manufacturing, then you can be more cost competitive, first thing. Second thing is that you should also create your own raw material ecosystem. This will ensure that your supply chain is well established within the country. The third thing, even more bigger vulnerability, is about the equipment manufacturing, which is currently standing at zero. I don't know if I can talk about this in an open forum like this, but there are some rumors from China that there can be a ban of ingot wafer equipment manufacturing equipments. So if that is going to happen, we are completely doomed. We don't have any kind of ingot or wafer manufacturing expertise, be it in the process or in the equipment or in the manpower supply or any such things. And at least 3 companies have been qualified in PLI for close to 30 gigawatt, each 10 giga. So I'm still, I don't know what to say, but this can be a very big problem for all these manufacturers. Although when we look at suppliers from Europe or US, they do have this expertise, but not at the level of what Chinese guys are going ahead, be in terms of automation or MES or productivity or the kind of AGVs that they are actually showcasing. Last time when I visited China in, I think, June or July this year, I was amazed to see a 50 gigawatt single location factory, and it's called a dark factory. This concept doesn't even exist in India, actually. It's a dark factory is basically there will be no lights inside the manufacturing place. It's completely run by automation, completely run by AGVs, zero manpower. So this has already started in China, and we are taking so much time, even for finalization of land or so many other problems, which is actually difficult to express here. In fact, even in my company, it took almost 2 years for us to finalize the land. Then when I wanted to compare how it works in China, it works very easy there, because when a manufacturer wants to go for, let's say, a cell line or a module line or an ingot wafer line or a polysilicon line, whatever it is. So all you need is to contact the government and come up with a proposal for that. The government clearly checks the technology sanity of it, and then the government allocates land, free land. The government builds the building. The government gives the utilities meaning the water, power, and all those required things to run the factory. And then all you have to do is buy the equipment and start your manufacturing. All this for free. So first 5 years, you don't have to pay anything back to the government, and you have to start paying after 5 years. Unless such things is going to happen here, it will be extremely difficult to compete with China. I should not say compete, because we are nowhere near. They are well ahead of us. So this is the current situation. But answering your question, so we still have our own big market within India. So if we can focus on integrated PV manufacturing, create our own raw material ecosystem, and then the technology agnostic, like introduction of AGVs and high-level automation, then it's practically possible to be cost competitive.
Thank you so much, Bala. Very, very important insights. And this is something that maybe the others can also reflect on as you share your thoughts, that are some of these challenges very similar in the sector itself. I'll come to Rajender next. So the supply chain for wind energy technologies has been far more matured in India compared to solar. It may be one of the key reasons has also been that there are smaller components or easy to manufacture components that may be easier for MSMEs compared to solar, where many of these are technologically complex. But given your Envision's experience of setting up some of these in India, what worked, what did not work, and what are the kind of policies that you think should be implemented or maybe scaled up further to increase the domestic value add for wind energy in the country?
Thank you, Rishabh. So Envision mission itself talks about net zero partnership. Maybe when we work with the customers or maybe the deploying the system. To be frank, one of the key element here to reduce the carbon footprint from the logistics. So that's where the localization is more preferred option in the segment. As on today, like by 2024, we are trying to achieve 70% of the key elements are manufactured in India, and by 2025, we are going to have 80% of the local supply chain. That is Envision already carrying it. And we have a factory in Pune, Chakan, where we are manufacturing our nozzle and hub assembly, which is almost having 3 gigawatt output per year. It's already up and running. And last year we invested 250 crore above for a plant in Tiruchi for our blade manufacturing. And we have the blade manufacturing setups are located across India to cater the customers in the west as well as in the south. West we have factory in Gujarat, and we have a factories in Tiruchi and Bangalore with a cumulative output of 2.5 gigawatt per year. So that is already pretty much matured enough now. And on the tower side, we have 10 various manufacturers across India. They're already catering for customers. which are existing with us and are going to partner with us to reduce the logistic as well as to reduce the footprint required and even the timelines. So that's where we are already deployed so many systems in this way. At present, almost like we localized our Nasland hub as well as the blade tower. It's already done. And in near future, by 2025, we are expected to localize the generators, gearbox, as well as the cables, or even the electric drives. So those can be done. So there is no friction at this moment, I can say, because the sector is booming and there are like a lot of opportunities for us to even so many suppliers can enter now. And the policy side, we are pretty much happy with the existing the tenders and the volume we are getting at, and we are almost booked like 5 gigawatt order. At this moment, like the only friction we are facing on the project development timelines, majorly we are expecting like 1 year or 2 years is the timeline, but because of the RO issue, road clearance issue, those are extending up to 3 to 4 years. This is a big pain point that need to be addressed on the local level. And the second major criteria is on the grid connectivity. Unlike solar, like solar you can connect to a local substation, whereas in our case, like we have to go with the ISTS substation construction itself. That's a time-taking process, and that approval is also stringent norms now. So these need to be looked into a very detailed level, and we need to focus on that. And the third point of view, like the supplier ecosystem still need to be progressed. If you take that for casting of the blade and for this phenomena, we have only 2 to 3 suppliers for wind, whereas if you go with automobile sector, you have 20 to 30 players. So that is pretty dominant. So we need to have the dominant player enter into this sector as well. So these are the challenges need to be addressed.
Thanks, Rajender. I'll come next to you, Vijayanand. We've heard different kinds of stories, both for wind and solar in the past. Solar, of course, the country is trying to scale up. Wind, it has existed. And similar is the case for batteries. As India tries to deploy more, it is also planning to manufacture more. But there are a different set of challenges. While maybe in the second question, we'll discuss lithium-ion batteries. But I want to understand given that your huge decades of experience from setting up lead-acid battery supply chain, developing some of these vendors, taking them along, what are the parallels that you can draw that worked for lead-acid that can potentially work for solar, wind, maybe even regular, as in lithium-ion batteries? What was the role maybe of policy, of industry, of various manufacturers? So, and what can potentially be done based on the learnings?
Thank you, Rishabh, for having me here in this panel discussion. We've been having these conversations around challenges associated with battery value chain development based on domestic manufacturing. If I go back 30 years ago, when we were just about starting our battery business in India, we adopted at that point of time what is seen as the latest technology even within lead-acid batteries called wall-regulated lead-acid batteries. They were non-existent at that time in India, and whatever little that was there were mostly imported. Lot of purchases were done predominantly by government agencies those days, whether it is the Department of Telecommunications or the Indian Railways used to be the biggest buyers of lead-acid batteries then. Even otherwise, it's PSUs who are buying batteries for industrial applications. I think the watershed moment for battery industry in India, at least on the lead-acid side, has to be considered as the mobile networks. Because what it meant is to have the wireless mobile towers to be located all across India at different points in the thick of urban societies, in remote national highways, in deserts, to have the coverage, which meant you needed a product that can work without manual supervision. You needed a product that's maintenance-free. It's a stroke of luck that we actually brought the VRLA technology into the country, which fitted into that application very well. But the speed at which the mobile networks were ramping up at that time, actually in 2008, the tower companies came into picture. Even before that, operators were setting up the networks. And each of the state, which is called the telecom circle, there were towers being set up by each operator at 100 towers a month by each operator, which means 3-4 towers a day by each operator. And if there are 3 operators, you're talking about 10 to 12 towers being set up every day. And the supply chain that's required to support that kind of a telecom network expansion, required to support it, and battery was again a very key element of it. Now, if you go back and look at how that supply chain evolved, incidentally, lead acid has a relatively simplified chemistry. The number of components that go into a lead acid product is not as many as you see, from the periodic table. Lead being one of the important thing. Then the separator material, whether it is a polymer-based separator or glass mat-made separator, or the plastics that go into housing the electrodes. They were non-existent at that time, but we were able to work with global supply partners, look at what can be done domestically to create manufacturing value here, and what could not be done from a commercial consideration. And the prioritization was clearly done. And luckily, even lead acid, the circular framework has been maturing. In developed markets, it matured. It means how do you treat the product at end of life? How does it get back into the recycling loop? And how do you recover the valuable materials out of it through the recycling process? Incidentally, for those who are not probably well informed, lead acid battery is the second highest recycled product in the world. And the first one is the aluminum Coke. The Coke, can, the aluminum can of the Coke. So 99% of what goes into a lead acid battery can be recycled. That's a level of maturity. Now the logistics associated with that, the environmental factors associated with that could vary from geography to geography. But fundamentally, if you look at the material balance, you can recover 19% of what goes into a lead acid battery. So now come back 30 years later, today, I think I said this earlier, but it's important to note that lead acid industry in the country ticks off every line item or a box for definition of Atmanirbhar. We have strong domestic manufacturing capability. 95% of what goes into the battery is made locally here. And the product technology has matured to global standards. The manufacturing technology is matured to global standards. And in fact, some of the applications that we cater to in India are more challenging than elsewhere in the world. So we have been able to develop products to meet those applications challenges as well. And in the end, as a country, we are a net earner of forex revenue, including what we spend on capital items, what we spend on material imports, and what we export as a finished product. I would love to see the lithium following that kind of a track as we go along. But then the similarity ends at a certain point of time. I would draw 3 challenges or 3 dissimilarities when we look at the lithium value chain or the EV battery or energy storage battery value chain. Number 1, it's a significantly higher capex heavy kind of a investment. Now, if I look at the revenue to capex ratio, in a lead acid battery, you get about $2.5 for every dollar of capex that you invest. But depending upon how the cell prices will go through, I think it's right now 1:1 and sometimes actually 1:0.8. For every dollar that you put in, probably you'll only get about $0.8 as a revenue. If the cell prices are going down faster than the capex, maybe that ratio is going to be more unfavorable. So you need to make your capital work for you. The second, I don't think by any stretch of imagination today we can assume that what goes into a cell technology has matured. It's still evolving. And the capital investments that you make are not that easily fungible to adopt futuristic chemistries, futuristic technologies, the form factors that the industry would prefer along the line. So you're taking a bet on that as to where you want to put your dollar. And of course, the third, which probably is the most significant thing, is the supply chain of critical materials is a lot more influenced by global policies, global politics, and availability of material. I keep reading that if you want to set up a gigafactory in China, you can do that in 18 to 20 months. I fully agree with what Bala said about, government in China is your infrastructure partner. Government in China is your service partner. All you need to do is put your money where it matters to you and create the capacity. Of course, we have a different set of challenges here. Now, being part of Indian industry for 30 years, I can't solve the problem by complaining about it. We'll have to figure out a way of solving the problem. But the bigger challenge on the material side is, while you can set up probably 3 years is what it takes to set up a gigafactory in India, but if you go back and look at getting materials out of the earth from the ground, sometimes it could be as high as 7 to 8 years. Now we talk about lithium deposits being discovered in Jammu and Kashmir or Rajasthan, or now more states are getting named for that. But first of all, we need to know what's the quality of mineral available there. Is it enough concentration for you to profitably extract it? Do we have the right kind of extraction technologies available, refining technologies available? The environmental implications, it's heavy water demanding kind of a thing, heavy power demanding kind of a process in the mineral processing there. It takes 7 years, sometimes even 10 years, depending upon where the minerals are located, for it to be made useful for the industry, in battery applications. So those are the challenges. So we are talking about technology volatility, we are talking about capex heaviness, and we are talking about the critical mineral supply chain related issues.
Thank you so much, Vijayanand. Very helpful. And it's a very good segue as I come to you, Priyanka, next. Given the scale at which Umicore is operating, it would have not been an easy journey, definitely, right? To recycle many of these materials, but also figure out the reverse logistics of collecting many of these. I mean, of course, lead acid, we are able to get all these batteries back in the system, but I'm sure it has been a learning process so that it does not end up in the landfill itself. How did maybe Umicore solve that? Are there different strategies for different countries? What worked for India? What did not work maybe in other countries? But more importantly, as India, there's so much focus on recycling generally, on circularity and the life principles that the government has now come up about. So circularity is also now a very important component across policies. But setting up that facility is not easy. It's not a basic mechanical, I'm sure, step. There's a lot of chemical industrial processes. So what are the basic threshold requirements, both in terms of finance, infra, skills, that have worked maybe in your favor? But what are the things that the policymakers should be aware of as they also try to revamp some of these so that maybe domestic jobs can be created and also add to the local economy and solve some of the problems that Vijayanand was saying is availability of critical minerals?
Thank you, Rishabh, and very glad to be part of this panel. And thank you all my fellow panelists. I hear you and I'm fully with you on this. Representing Umicore, what we can say is we have been in the recycling space for the last 135 years. Circularity of precious metals has been our business now for more than 30 years. So yes, we do, as a corporate, we do have certain global expertise. Quite a bit has been trial and error, quite a bit has been learning and growing with the market. But something that I would like to highlight, particularly with India, recycling in India has gained momentum quite recently with respect to the rest of the world. Maybe 5-7 years is when it has really taken a lot of traction. And any recycling, be it water, plastic, chemicals, low metal, high metal, any recycling is not easy. Sounds easy, but it is not. Various steps involved. Just to have a broad idea, recycling should be divided into two parts. One is the physical part, which is basically the collection and the pre-processing bit of it, which is more physical, which is more manual. That requires low capex, low skill, lesser time. But this is also where the safety of the people who are handling it becomes very, very important. Sustainability and safety towards the environment becomes very important. And that can be taken care of if we have very clear, stringent regulations and policies which are also enforced with the same vigor. Here we would require the central and the state bodies to work together as a single entity, and let it be known that there are going to be consequences of non-compliance at this stage, you know. Having said that, this is also a very important part to take care of the overall logistical and supply chain efficiency in any recycling step. Because the level of efficiency with which the collection is happening, with which the pre-processing is happening, is all going to determine the level of efficiency of the next step. So it's all going to build up, unlike a few of the other industries. It's all cumulative. And here, it will be very difficult to correct a loss or leakage of valuable material, which today we are seeing a lot moving into the uncontrolled or the unorganized sector. Once that happens, once the leakage of any material, any recyclable material which we see as value moves into the unorganized sector, there the value, the ROI on the capex will not be as good. There the efficiency, the operational efficiency which we want to achieve will not be as good. So here we need both the industry and the policy makers to come together and prevent that leaching here. And this all happens at the first part, which is not even the chemical bit yet. Now, when we move to the second part, where we have got a pre-process, critical mass input, that's where it becomes a little bit more physico-chemical or chemico-metallurgical, and that's where the technology comes in. That's where high capex, high investment, technology, highly skilled workforce, all these become important. And again, the level of efficiency which you have brought in with the logistics and the supply chain are all going to impact your overall recovery. Now, here there are basically 3 or 4 things which we need to be very mindful when we're looking at recycling. First is we need a critical mass and a scalability, because in absence, and this is applicable for any kind of recycling, any lack of critical mass or scalability is not going to give us the operational efficiency which we require. If we do not have the operational efficiency, we will not be able to have a process stability, which means we will not be able to have the same kind of results again and again. And in absence of that, there is no cost efficiency. Then it doesn't make business sense at all. So that's very important, which is where I go back to my point of leaching of valuable material from the organized sector to the unorganized sector needs to be contained well, and we have enough material. We can be doing that. Second is, once we do get into this space, it's a long-term game. It needs patience. There is, at certain point of time, high capex involved, high R&D costs involved, high OPEX involved, because the ROI is going to be longer. So any player getting into this has to have that long-term view in this. This is not, I know many startups have come into this, but it needs to be a long-term play to do it the right way. No cutting corners. Third is availability of manpower. Yes, today, India, we have a lot of people available who are speaking English, who are basic educated, but the kind of skill that we require towards batteries, towards recycling, towards renewable energy is quite different than what we have so far. So while unskilled labor, we can still train, but the skilled part of it, I don't think there are enough curriculum or enough academic institutions offering enough curriculum to cater to the kind of growth that this industry is going to see. And then what happens is there is, a lot of movement between competition and practically a bloodbath for the experienced resources. Fourth point would be the kind of policies that we look forward to, single entity with absolute clarity and enforcing it. That should work as a deterrent for people who are not complying, and as a beneficial, a benefactor for people who are compliant, because there's a lot of cost involved to that, to being compliant on that. And of course, this requires a constant R&D. This needs to be very, very adaptive, very modern. But having said all of this, right now it sounds like a challenge and a problem, but this is going to be the need of the hour. None of the industries today, none of what we are representing here, none of the retail industries, none of the manufacturing industries are going to be efficient in terms of operations or cost if they are not getting active into recycling. In the next 10 years, it's going to be the way of life. So maybe 10 years later, our challenges would be different. And I look forward to that time.
Thank you. Thank you, Priyanka. And I'll come to you, Bhaktha, now. We've heard about the challenges of critical mineral availability, and then, of course, the opportunity of recycling. But you are solving some of these through a different lens. What if we don't require some of these minerals? So maybe for those who don't know, you can briefly also explain what you are up to. But what was the motivation for you to start the process of innovation, if I may call that? Or even how did you come to that problem statement that you would want to solve? And then how easy or difficult has it been for you to commercialize the technology in the Indian EV ecosystem, in the Indian ecosystem? So happy to hear, but maybe if you want to take some time, because I know compared to others, you're working, you're doing an innovation, and especially on a very important product. So, yeah.
Thanks, Rishabh, first of all, for having me here. So the main motivation to answer Rishabh's main question as to why we are doing this at Chara. Chara is the name of the company. I think most of you guys have seen this, right? And I have been in this, I was in this industry before. What is amazing for me being in India is that, do you know how many of these components, or what percentage of these components are made in India? Like, I don't know, like what, 0? We can start from 0, but it's a slightly higher number. So, I was part of building this phone in the early 2000s. And 20 years later, everything we are dependent on foreign countries. And there is a huge energy transition that is happening. Rishabh is a big proponent of that. We are moving away from hydrocarbons to electrons for our energy, which is all good. So when we have this transition and we move into an electric future, there are two things that we worry about. Batteries, a lot of people spoke about it. And there are motors, the future engines. And if we don't do anything, our EVs will become like this. We'll be dependent on foreign sources for, as he said, for technology and critical minerals. And that's what, that's when I thought, we should make an attempt. Having said, a problem is always an opportunity. That's what we think. Startups, that's what we think, right? We're trying to solve problems. And that's where we ended up looking at how do we solve this huge problem and also a huge potential. So briefly, the work we are doing, and just to put into context, there is this energy transition happening. The future engines, the electric motors are very important. Most of the efficient motors, especially the ones used in electric vehicles and other high energy appliances, have these magnets in them, Nd, Feb magnets, neodymium, ferrous boron magnets. These magnets need rare earths, neodymium and dysprosium. If you're not heard about these rare earth minerals, please go to google.com and start looking at it. It's going to be critical for our future. A lot of people like me did not pay attention in our chemistry classes in high school. There is this, at the bottom of the periodic table, separate from everybody else, there are these 15 elements which are critical for our future. Neodymium, dysprosium, samarium. They're used in batteries, they're used in motors, electronics, defense equipment. And these rare earths have a few problems. Number one, they are expensive. Number two, they are difficult to mine and extract. These are called rare earths not because they're rare. Gold, silver, aluminum, they are all rare. These are called rare earths because we get about few hundred milligrams from a ton of ore. That means we have to process lot of ore to get a few grams of this critical minerals. And we fundamentally believe, and I have no proof, that the mining and extraction of rare earth minerals are not environmentally scalable. The waste products we get from this extraction is radioactive. There are cancer villages in some country whose name I shall not mention because of this rare earth extraction. Last but not the least, again, as Vijayanand said, critical minerals are becoming a geopolitical problem. There will be a new way of colonization, rare earth mineral colonization, and we need to get away. There are many solutions to this problem. One is, of course, we have to recycle more, which is, I believe, the best way to do it. Actually, I did not know that 99% of the lead acid batteries are recycled. That is just amazing. We are nowhere close to that in this new world. Then we can also find alternate materials, which presumably have these properties. So we're talking about fundamental improvements in material science. People are looking at it. If you take the Department of Energy in the US as a kind of a indicator as to where things are going, they're actually funding projects now. We believe that they're about a decade or two away from becoming mainstream. That means substitute for these rare earth minerals. People are looking at sodium-ion batteries and a bunch of other things. But what we are doing now, briefly about us, we have to tell us, we are a startup, so any opportunity we tell about what we are doing. So we are building motors and controllers completely from scratch, which are completely free from rare earth minerals. So rare earth-free motors for electric vehicles and other high efficiency applications. So we have now built motors and controllers for two-wheeler, three-wheeler, small four-wheelers, and industrial applications. I'll just take one more minute to answer the second part of Rishabh's question. How difficult was this journey, and what are the hurdles we faced? Any startup is hard. It is ridiculously hard. Building a business is hard. But building a deep tech, hardware-based business is hard all over the world and harder in India. So we had a lot of difficulty raising. Unfortunately, we need a lot of capital. We had to do fundamental R&D. So we had difficulty raising the capital. Having said that, we have gone through 2 rounds of funding. Then the second part was the finding the right people. As Priyanka said, we have a lot of engineers, millions of them, but none of them have worked on products. As a nation, primarily, we are a services nation. So that is a huge problem we faced. And the last one, commercialization is actually the easiest part for us because we are solving a critical problem. There are customers we have signed up, there are customers coming to us, and we hope to go into production soon. I'll stop my...
Thank you so much, Bhaktha. Maybe I'll come next to you, Bala, again. So we, of course, discussed the various steps in the manufacturing and some of the policies. But as I was quickly going the area now, I've also realized that there are different solar module technologies that are now being commercialized or launched. And if you see the typical graphs, it will still be mono and maybe monoperk and a couple of others. But given how some of these technologies are improving or changing or new technologies being commercialized, do you think to secure the supply chain, the government should focus on a couple of them or continue to remain technology agnostic and let the market, the global market, determine which is the best technological winner? In that sense, always the low cost and of course meeting all the basic conditions. Or do we then pay a premium and say that this technology or the indigenization of this technology works best or is possible in India, and then we focus on that? So how should the balance between these be addressed, and what can potentially the policymakers do?
Yeah, as you rightly said, there are so many technologies available in the market like PERC, TOPCon, HJT, and nowadays you hear about perovskites, tandems, and other technologies as well. But as far as my opinion is concerned, I think government should not be technology agnostic. It should let the manufacturer to decide what they wanted to do. See, in many situations, the market is mostly goes in favor of cost competitiveness. Finally, it all boils down to dollar per watt peak. So in that sense, you still see that PERC is still a front runner and TOPCon is picking up. And HJT, we don't know, maybe after a few years, it might pick up or it might not pick up. Instead, actually, government can push for technology through their government R&D labs or through several innovative technology institutes like IITs and IIScs. They can set up their own national labs where they can help us to come up with different kinds of technologies, how it can be manufactured, which can be more cost competitive, which can be more technology efficiency. So these are the ways that government can actually push for the manufacturers to help. But if they specifically are going towards high efficiency, then things might not work in their favor. So this is my opinion.
Okay, thank you, Bala. Vijayanand, if I may come to you next. So we often say, and many of these PLI policies are asking about high indigenization level. So in solar, at least I think Bala would need to meet 90% indigenization in 5 years, 90% from polysilicon to modules. Batteries, I think it is 60%, and similar is the case, so it varies. But when we say strengthening the supply chain, we always say indigenization without quantifying what does that indigenization mean. So now, what is your view? Do we completely indigenize, which means 100%, or do we 100% of the whole value chain, or do we indigenize some components which are time consuming or there's lag? So we know that if we start today, maybe we'll take 10 years to indigenize a particular component manufacturing, maybe cathode, anode, whichever ones, or do we do 30% of everything? So should there be a preference as how we are thinking about battery manufacturing in the country, so that accordingly the government can maybe frame policies for the country? So,
Rishabh, there are two challenges to look at it here. One is how much indigenization we should do to meet domestic market demand. And second is to look at, as we do indigenization, if you identify certain strengths within the supply chain that India will have, can you then look at meeting some global market needs? And that's not necessarily indigenization, that's creating domestic capacity to meet global market demand. I think we need to have strategic approach to both. I agree with you that don't indigenize by just targeting a percentage. Prioritize what makes sense in the long run. Create strengths in that, because if you want to indigenize, what's the motivation? One is material security, that you have access to material. Two is cost competitiveness. If neither of them are met, doing indigenization for the sake of doing indigenization doesn't make sense at all. So it has to meet one or both of these goals. So prioritization of indigenization has to look at how am I going to meet these material security and cost competitiveness, and attempt at them. Now, while doing so, you might end up finding that some are very, very capital intensive. So you'll have to also draw the equation that, am I putting the dollar where it's really matter? The second aspect is, as in the process, maybe in the 3 to 5 year period from now, we might end up finding that we have certain natural strengths. And if we believe those are the natural strengths that we have, do it for the world. I mean, when I say for the world, we talk about 3 specific strategies there again. It's China plus 1, which means you want to be, an alternative to China. It could be anything but China strategy. There's a call ABC. Somebody says that, I want to source it from anything but China. The third could be that, I was just checking the statistics. The global population is 8+ billion today, and G20 countries host about 5 billion people. Where are these 3+ billion people outside G20 countries residing? What's the kind of evolution of these societies, these markets, these countries? And can India focus on building solutions that will meet the needs, current and future needs of these markets? And we are very clearly seeing that. In the EV space, while there will be always Tesla buyers in this country, the prioritization is to look at local light electric vehicle mobility. We talked about that in another conference where light electric mobility will be the dominating need. 70% of passenger miles in this country are achieved on two-wheelers and three-wheelers. Even oil consumption, I don't have exact statistics, but I believe that close to about 70-75% of what we consume as petrol or diesel goes into these light electric vehicles. And luckily, the entry barriers for conversion of a ICE vehicle to EV is far less in this space. TCO is achievable, technology is not complex, access to materials and access to components is relatively easy than complicated high-end powertrains. So if we focus on that and then meet the domestic need, in 5 years from now, we will discover that our ability to design powertrains or light electric vehicles is probably much better than anybody else. If you just count number of vehicles without worrying about how big a battery pack is inside the vehicle, India might actually become the highest population of EVs not too far in the future. So if you're going to build strength around light electric mobility vehicles, why don't you cater to the world in that space? Innovate there. Innovate vehicle design, innovate powertrains, innovate business models, swapping. People look at it with doubt. I have a feeling that it has its place. I know we are not going to solve the problem by just using one solution. So if we are going to build a innovative business model and innovative product portfolio for swapping application, perhaps there are markets outside waiting for that. A country like Taiwan has done it with Gogoro. So I go back to the comment earlier one of the panel members was making. We have lost the competency in the engineering to deal with materials, deal with material processing, design products and all of that. A Singapore or a Dubai or probably a Taiwan can get away based on services, but India needs industries, India needs product designers, India needs material scientists, India needs manufacturing ecosystem that deals with materials at molecular level. Life sciences talk about molecule management, material manufacturing, subcritical minerals talk about molecular this thing. I will just close by making one statement that in EV, there's something called molecular tourism. You might find that the cobalt residing in the cell inside a EV running in India, probably in an imported EV, would have probably traveled 160,000 kilometers from the time it is picked up from the ground. That's molecular tourism. Do we really need it?
Interesting point. Good that you mentioned that there are 3 billion people in the non-G20 countries. I remember I was visiting one of the Central Asian countries, and the cars that are plying on the roads are mostly second life cars from Europe, and they've already run 200,000, 300,000 kilometers, which also means that if you're not innovating for them, they are using inefficient vehicles, right? So that's also an added cost for the energy transition. So if we are able to innovate for the low-income countries, we can directly get them to leapfrog to innovative technologies and then combating, instead of them using low-efficient, second-use equipments or materials.
Yeah, just a quick comment. I think today, if you look at Western Europe and North America, most of the vehicles, personal use vehicles, are 2-liter and above kind of, IC vehicles. It started sedans, then went into SUVs. Now they talk about pickup trucks and all that stuff. I think EV is going to create a vehicle category which talks about neighborhood mobility. Climate being what it is, maybe you can't use it during winter times, but rest of the seasons, you will have a small electric vehicle that's good enough to move around next 10, 15 miles. You don't have to have a 300-mile range for the battery.
Interesting. I know we have 5 minutes, so is it okay if we run for 5 more minutes, additional minutes? Okay, then we'll ask the panelists to be brief. So Rajender, if I may come to you, as we often discuss indigenization of batteries, I know Envision is also into batteries, we focus on cells, but there's significant assembly capacity also that exists in India right now, because that's maybe the first step, and then maybe you go to the next steps. What are the challenges and opportunities as companies are trying to first indigenize that part? Even though it's assembly, it's a complex process. And what are the opportunities that you see there, and what are the challenges that you would have faced? You
Thank
can
you,
be
Rishabh.
brief because of the time. Apologies for that. But yeah.
Thank you, Rishabh. So there are like 3 steps we can take ahead, like as per even Niti Aayog mandated, even as per the regulation. One is we can just import the cell and rest of the components like the packing and even the cell interconnection, as well as with the rack casings that can be done in India. Along with that, maybe the key supply chain, like those are like knowledge hub for the system to work, like the battery management system and customized cooling units, which are pretty much available in Indian supply chain, but they are not defined for EV or BESS. Those are still at not mature level. So we can focus on that first and have some base in India. In the next level, we can go ahead for the R&D setup. Even the companies can have a joint venture with the gains in across the world, in the Europe or maybe in China, irrespective of the nation. Then where we can bring the knowledge know-how into the battery manufacturing, in the BMS system or in the liquid cooling system, and existing ecosystem can evolve into that and made the specific product to capitalize that, that make some money out of it. And in the long run, if you see, we can actually import only the cathode, maybe the anode and in the electrolyte as well as the separator. These can be do it in India. Again, it's not about the raw material alone, but still, if you see the current market stage, like 95% of the anode is now focused, like LFP, it is in China. And if you go for electrolyte, of 85% of global supply chain coming from China again. So there should be some components, maybe we need to Indianize, maybe even by going beyond the technology, maybe instead of only going with lithium iron phosphate as an anode, sorry, for the cathode, you can going with LMFP, maybe with the manganese doping you can do, and we can go for solid state batteries, like we said. So our sodium ion batteries, our R&D can expand in that way that we can go ahead with China plus strategy. That is one way. And the second, even, so that way actually we can leverage the whole supply chain that can concentrate up to 80% of the value chain of the industry. That is a possibility. At present, just to meet the demand, to make the market viable, we need to import some material and have the policy such a way that maybe some countries are having the free trade agreement, they're able to make us our supply chain now. But there is no clear-cut credentials, like only cell and pack having the priority, but only the 5% value chain, like the BMS or even the firefighting system or the liquid cooling system, those are not yet defined in that value chain. That need to be come under the clauses, like by reduction in the BCD, just to cater the segment at this moment, at least to be reached like 5 gigawatt of kind of level. Then we can hope for more supplies come into the picture.
Okay, thank you. I'll come next to you, Priyanka, and maybe you touched upon some of this in your previous comment also, that many countries are now trying to indigenize, recycle, but the focus, I think, what we've seen is that they want to increase the domestic value add across the value chain, get more jobs, add to the economic growth. So, and there can be policies that countries will start implementing so that some of these ecosystems start them. So in solar, we have basic customs duty as high as 40%, so that solar domestic manufacturing is competitive. Similarly, there are countries which may then end up, like they're doing mineral ban, may also do scrap bans, right? In a scenario like these, what are the policies that will bring, say, companies like you to India to maybe do some of these maybe basic processing, and before you export to maybe the industrialized hubs, or maybe even set those in India? So what are those ecosystem barriers that exist, and what are the changes in policy that may be required?
Absolutely. Thank you, Rishabh. Very pertinent question. And see, today, what time? See, for any corporate MNC, India is very important and very strategic. So we want to be very close and as close as possible to the market. Having said that, my suggestion would be to policymakers should be to look at indigenization as a slightly long-term strategy and first create demand locally. So there should be an incentive for people to put up capacity, put up an investment, create the demand, create a level playing field where a startup and a huge, multi-thousand crore company are able to compete with the kind of products they are simply because of the, the scale which is being produced. Having said that, there will be a need of a lot of collaboration in terms of technology, know-how exchange. There are different models which can be used, like, it could be a reverse service provider arrangement or toller arrangement to begin with until we have an evolution of the market. The end game should be Indianization. But to expect that that will be the first step which we will go is a little bit unrealistic, because then we are competing with the likes of China, which is far more evolved in terms of capacity, in terms of government support, and the whole process. So it needs to both need to move in tandem. First with the international collaboration, because looking at one world, which is also a G20 mantra, and then have an end game towards that.
Thank you, Priyanka. And I'll come to you, Bhaktha, next. All of us have spoken about the hardware for energy transition. But one of the things that you had mentioned in the previous conversation is the importance of making some of these systems smart to actually make an impact on the ground. So what are your learnings and how are you making your products, motors, smart enough? And what is the role that the software plays into the success, commercial success of your product? Because if India is an IT hub, some of those expertise should also be then leveraged for the energy transition. We are of course starting at maybe the early stages in many other sectors, but maybe IT we can be the front runner and maybe solve for that. So your views on this?
We'll keep it super quick. 2 points. One is that what we are doing, the motors and controllers we are doing, the hardware becomes very simple. You can build a motor with pretty much aluminum, steel, and copper. Manufacturing is easier, but the complexity of that motor is in the control algorithms. So the complexity shifts to the software. And I say presumably, we are a software nation. So we should have naturally more advantage in building these kind of motors and controllers, and also a huge ecosystem around it. And the second point is, at a broad level, I was in fintech before. I'm a hardware guy. We have to digitize the electrical grid. What this means is that, as you can see, I'm an old guy. When I was, started earning money, we used to write paper checks, and we used to go to the bank. And now everything is completely digitized. I can pay 10 rupees just like that. I think we need to get to the same level for energy, and the future is electric. So we need to get to the same level where we can trade, store, and transmit and consume energy in a far more efficient way than what we are today. Thanks.
Thank you, Bhaktha. So with this, we'll close the panel discussion. I hope all the participants found it interesting and informative. But thankfully, because of the panelists, we are able to cover a wide spectrum of technologies and able to discuss the key challenges, roadblocks across the value chain. What we are seeing right now in India and globally, that there is a huge push in technology development, manufacturing, indigenization. And given that India, even though it took baby steps few years ago or maybe in the last decade, some of those are acting as a multiplier effect. So any even larger steps that we take now can serve the country in many different kinds, in maybe in the decade of 2030, 2040. So we should be prepared with solving some of the challenges that exist. And hopefully, I mean, you have the veterans here, but maybe through more discussions and maybe supporting through policy, we'll be able to reach there. So thank you again, all the panelists for joining and the participants. Thank you.
Thank you. Well, thank you so much. I guess this is the amazing session we have witnessed today. Thank you, our audience, for being patient throughout this session. And now I would request our respected moderator, Mr. Rishabh Jain, please present the token of appreciation to each and every one of our panelists. So can we have the memento, please? First of all, I would like, let's have a group picture. With a huge round of applause, everyone. Can we give them a huge round of applause? Because this session was actually quite amazing and informative.
Hello, check. Ladies and gentlemen. Hello, sorry, I think the mic had a problem. So good afternoon. We also have Mr. Rajneesh Khattar, who actually got Renewable Energy Expo, from 2008 to 2023. We are still in our 16th year. So I just got hold of him and wanted to get him on the stage. Yeah? Mr. Khattar, please.
Thank you, Amit, and thanks everyone. Dignitaries on the dais and off the dais. My extremely apologies because I've just got off with the opening ceremony, and but all I can see that there is so much of enthusiasm, and I'm getting a lot of regular reports from the registration counters, the amount of registrations which have happened, and the kind of traffic which has already moved in. I think all the halls the floors are buzzing, and I think this couldn't have happened without your support. And I'm sure, though I couldn't be part of the deliberation, but I can imagine that it must be a great piece of, deliberation, and the experts on the dais must have showcased and discussed something so purposeful and so meaningful, all of you. Thank you for joining us, and thank you so much.